Hello, Algebra! Today we're going to start lesson 4.2, which is writing equations in point-slope form. So if you are given a point and a slope, it is easiest to write the equation in point-slope form, especially if that point is not the y-intercept. So we're going to take a look at this, okay? So point-slope form is y minus y1 equals m parentheses x minus x1. This X and Y right here, the ones that are just in black, you're going to write that every single time, okay? And then we have three things we have to substitute into this equation, all right? We have three things, and I've color-coded them. Slope is green, my M. The Y coordinate of the point is yellow, because Y in yellow makes sense in my brain, and then X is in red. So let's take a look at the example down here, and I will zoom in. There we go. And we're going to start right here. So we have a point, 1, 2. It is not the y-intercept, right? Y-intercepts have an x-coordinate of 0. So this is just a point that's on the line. And we have a slope that is 7. So I am going to color code my slope. I know it is 7. It's my m. And then I need to look at my point here. Well, which comes first alphabetically, x or y? X does. So that means my x1 is going to be 1. And my y1 is 2. So now that I've color-coded them, I can actually fill them into my 3 blank boxes here, right? So I'm going to write down y minus 2 equals 7 parentheses x minus 1. All right, and that's all I am doing. So there's my y coordinate, my x coordinate, and my slope, nicely color-coded. And that's all this part said, was just to write it in point-slope form, right? I'm just plugging in my numbers. That's all we're doing for this first one. So let's take a look at number 10 now. Why it's not 2, I don't know. My numbering's off. So we have the point 3, negative 1, not the y-intercept again. So it's just a point on the line. And remember, it's a pretty star point. We'll take a look at the graph in a second. And then we have our slope that is negative 1. So my slope is negative 1. I know that that's going to be filled in for m. And then my x coordinate is 3. So we're going to do minus 3 here. Make sure you have parentheses, all right? Don't forget your parentheses. Those are very important. And then we have y minus, and in this case, it is negative 1. It's really important that you make sure you remember to subtract your coordinates, okay? They both have a minus sign in there. So when we simplify this, because I really don't like having a minus a negative, don't like it. So let's change that into y plus 1 is equal to negative 1 x minus 3. And now it's in point-slope form. Let's take a look at our last one here. All right, let's take a look at our last one here. So this one, we have the point negative 2, 5, and a slope of negative 4. So I'm going to color code my slope, and then negative 2 is my x, and 5 is my y. So I have y minus 5, right? It's my yellow, is equal to negative 4, x minus negative 2. X minus negative 2. And I'm going to highlight them appropriately so it helps our brains. So now I can rewrite this so that's easier because, again, we're minusing a negative. Don't want to write like that. So we've got y minus 5 is equal to negative 4, x plus 2. When we minus negative, we add. There are some more practice problems to try out. We'll do those hopefully during class, during our meet. All right, let's take a look at the graph now. Okay, let's take a look at the graph. So it says using 2 points, write an equation in point-slope form, then slope-intercept form. So first, let's just focus on point-slope, and we'll do some more from there. Now, I have circled a pretty star point right here. And you can see that it makes a perfect star, right? We've got our horizontal marker, our vertical marker, and then the line goes perfectly through it. So it's a beautiful star point. Let's find another star point because then we can find our slope because we know slope is rise over run. Now, you can also plug it into our equation y1 minus y2 over x1 minus x2. I'm not going to do that right now. We'll take a look at that in a second. So here's one of our beautiful star points. There are 2 others that are visible. Take a second, see if you can find them. Okay, there's one right here, and there's one right here, right? Those are where our other two beautiful star points are. I'm going to choose this one just because it's closer to the point I picked out. So we are down here, and I am going to rise 1, 2, 3. So I'm going up 3. And then I am going left 1, 2. I'm going left 2. So that means my slope is going to be positive 3 over negative 2. So my slope is negative 3/2. Again, I encourage you to leave this as a fraction. Okay, leave it as a fraction. It's just better that way. So now that I have my slope, I'm going to plug that in for my m over here. So I'm going to have negative 3/2. And then I need to pick out a point. And as I said, there are 3 different points to use. I have already picked out for negative 2. You can use either of the other ones. You'll get the same answer as me, all right? So my negative 2 is my y coordinate, and 4 is my x coordinate. So this would be y minus negative 2, and then x minus 4. So I can rewrite this as y plus 2 is equal to negative 3/2 x minus 4. And it says I want to write this in slope-intercept form. All right, so I actually have to solve this and get y by itself, because slope-intercept form is y equals mx plus b, right? That's what slope-intercept form is. So I need to solve this. So we've got y plus 2 is equal to negative 3/2 x minus 4. So I need to distribute my fraction. So we get y plus 2. Negative 3/2 times x is negative 3/2 x. Negative 3/2 times a negative 4. Remember, this is really 4 over 1. So I'm just multiplying 2 fractions together. So negative times negative is a positive. And then 3 times 4 is 12. And then 2 times 1 is 2. Hey, 12/2. I can reduce that down. So this is really y plus 2 is equal to negative 3/2 x plus 6. And then I need to subtract 2 on both sides. So we get y is equal to negative 3/2 x plus 4. Now, some of you are going to look at me and go, wait a second, we knew that. That's our y-intercept. And our y-intercept's right there. That's great. It's a good double check. All right, I'm going to turn the page. There are some more practice problems right here in your student journal, so feel free to try a couple of those out. Okay, we've got some function notation. It puts the fun in function. So we have f of 4 equals negative 2, and f of 8 equals 4. So this f of 4 right here, that 4 is our x coordinate. It's our x value, right? And then this negative 2 is our y value, or f of x value. Remember, f of x is the same thing as having y equals, right? Those two things are the same. Our next one right here is going to be the point 8, 4. So I know we're dealing with a lot of 4s. It's a little confusing. I'm going to highlight our y values in yellow and our x values in pink. So hopefully that helps your brain. It certainly helps mine. So let's plug it in and get our slope, because first we need to have a slope in order to use our point slope form. So we've got negative 2 minus 4, and then 4 minus 8, right? If we have negative 2 minus 4, that's really negative 2 plus negative 4, so we get negative 6. 4 minus 8, we've got 4 positives, 8 negatives, so that's a negative 4. Hey, negative divided by negative is really a positive. And then 6 divided by 4, we can actually reduce that down, right? They're both divisible by 2. So this turns into 3/2. So we have a positive 3/2. Again, I recommend you leave it as a fraction. So I'm going to plug that in over here, my positive 3/2 for my slope. And now I just need to pick one of these points. Doesn't matter which one. I'm going to go with this one because it doesn't have negatives, honestly. So my 4 is my y, 8 is my x. And then I need to solve it algebraically for y. so that I can get y by itself. So then it is in slope-intercept form. So y equals mx plus b. So I need to distribute. So we get y minus 4 is equal to 3/2 x. 3/2 times 8. Remember, this is 8 over 1. So that would turn into 3 times 8 is 24. And then 2 times 1. So minus 24 over 2 times 1 is 2. Which means it's really minus 12. And then I need to add 4 on both sides. So that gets us y equals 3/2 x minus 8. So we know in this case that our y-intercept is at negative 8. And our slope is still positive 3/2. So let's take a look at a word problem. All right, it's the last one we're going to do together. And there are more problems to practice on page 105 of your student journal. So this one says the student council is ordering foam hands to promote school spirit. The table shows the cost of ordering foam hands. Can the situation be modeled by a linear function? Explain. If possible, write a linear model that represents the cost of the function. Well, remember with linear models, we need to be able to have the same increase, right? Our slope needs to be the same. So if I go up by 5 on the x, I am increasing by 10 on the y. 5 on the x, 10 on the y. So is this linear? Yes, it is. Next thing we need to do is we need to find our slope. And you guys kind of already heard me say it, but let's do it anyways. So our y's, again, I'm going to color code them in the yellow. The y's are the cost, right? The y's are the cost. So how much I pay is dependent upon how many the school buys, right? How much the school pays is dependent upon how many the school buys. So you can pick any 2 of these. It doesn't matter which 2. I'm just going to go with these 2, all right, just because it's easier. And remember, the number of foam hands is your independent, and the cost is the dependent, just to remind ourselves we know that. So our y's are going to be 15 minus 25 over 5 minus 10. And we have negative 10 over 5 minus 10 is negative 5. So a negative divided by a negative is a positive. 10 divided by 5 is 2. So we know our slope is 2. So I'm going to plug that in over here. So our slope is 2. Next thing we need to do is we can pick any of our 3 points here, doesn't matter which one, and use it. I like to stick with smaller numbers, so I'm going to pick the 5 and the 15. So we've got y minus 15 equals 2, parentheses, x minus 5. Yes, the parentheses really matter. And now it says I need to solve it algebraically, right? I need to solve it algebraically. So let's distribute our 2. So we get y minus 15 is equal to 2x, right? 2 times x is 2x. And then 2 times negative 5 would be negative 10. Now I need to add 15 on both sides. And we have y is equal to 2x. Negative 10 plus 15 is a positive 5. It's a positive 5. So it says, if possible, write a linear model that represents the cost of the function for the number of foam hands. So another way of saying this is our slope right here, right? This 2. So every foam hand costs us $2. And there was like a $5 shipping fee. So even if we bought 0 foam hands, we had to pay $5. And that usually happens when we have shipping fees or things that are like that. Shipping fees are the ones that I can think of off the top of my head. All right, there are a couple more problems that you can try out on page 105. Email me if you have any questions.